Hey class, we're going to work some more on 2.7. We're going to go back over example 5 here. So remember, this time notice we have a fraction because we're dealing with the rational inequality here. And that just, we do it the same way as we did the others, except for now we're going to have to deal with the vertical asymptote as well. So start out just like before. Remember, you have to have an equal on one side of that, you have to have a 0 on one side of that inequality symbol. And so we're going to move that 3 over by subtracting it. So when I subtract it, I get 2x minus 7 over x minus 5 minus 3 less than or equal to 0. Then, in order to put those together, we have to have a common denominator. And our common denominator here is going to be the x minus 5. So we end up with 2x minus 7 over x minus 5 minus something over x minus 5. Well, I had to multiply that 1 by x minus 5, and remember what you do to the bottom, you have to do the top. So that means I'm going to multiply this top, this numerator, the 3, also by x minus 5. So I'm just going to write it out on this step here. And it's still less than or equal to 0. So then we can put it together as one fraction. I'm going to distribute that negative 3 and put it all over the common denominator. So we have 2x minus 7 minus 3x plus 15 all over x minus 5, which is still less than or equal to 0. Combine your like terms in your numerator, so you get negative x plus 8 all over x minus 5 less than or equal to 0. So here is going to be our inequality that we're going to use for the rest of this problem. From here, we now need to find our x-intercepts. How do you find your x-intercepts? Remember, your x-intercepts are where when dealing with rational equations, or inequalities in this case, is going to be where your numerator is equal to 0. Well, my numerator in this case is negative x plus 8. So I set that equal to 0 and solve, and I find that x equals 8. I've also, because it is a rational function, I've got to find my vertical asymptote. Well, your vertical asymptote is where your uncanceled factors of the denominator is equal to 0. Well, in this case, nothing canceled, so it's just where x minus 5 equals 0, which means I have a vertical asymptote at x equals 5. Now we're ready to build our interval table. Remember, your intervals are broken up by those x-intercepts and those vertical asymptotes. So let's get started on creating that table. Okay, so here we got our table started, and we just need to create those intervals. So remember, it always starts at negative infinity, and it's always going to end at positive infinity, and we just said it's broken up by those x-intercepts and vertical asymptotes in numerical order. So my interval is going to start at negative infinity, and it's going to go to 5, which is the smallest of the two, and then 5 to 8, and then 8 to positive infinity. Remember, your infinities will always have parentheses because you can never equal it. Also, your vertical asymptotes will always have parentheses. And we had a vertical asymptote here at 5 because you can never equal the vertical asymptote as well. It'll never cross it. It'll never touch it. Then, for your x-intercepts, you have to check your inequality. Look up at it. Does it have an equal to in it? Well, our original problem was less than or equal to. Therefore, the 8 is included, so you're going to put a bracket there. So now let's pick some x values that are in each of those intervals. Okay, so I picked some x values that exist in each of those intervals, and when I plug in the 0 into this function, I end up with negative 8 over 5, which then is negative. When I plug in the 6, we get a positive 2, which is positive, and when I plug in 9, I got negative 1/4, which is also negative. Alright, so to find my solution here, I'll look back at the problem where I said we would be using right here. It's less than or equal to. What kind of numbers are less than 0? Well, negative numbers are less than 0. So this one is negative, and this one is negative. So this tells me that my solution is from negative infinity to 5, and then union 8 to positive infinity. Now, this one also told me I needed to graph the solution set. So I'm going to draw my number line here. And I'm going to label all my important points. I have negative infinity down here on the left, positive infinity on the right. I have 0. I need to see that 5 and the 8 as well. Alright, so then when I go to graph this, I can see that it's going to be shaded from negative infinity to 5. So, and at the 5, we're going to put an open circle, or we talked in class about you could put a parenthesis there, which faced your shading, and then we're going to shade towards the negative infinity. Excuse me. So then at the 8, it's equal to, so the 8 we're actually going to put a closed circle, And then we're going to shade towards the positive infinity. And that is our solution for this problem.